hoping you are doing well. So today again at 9 p.m. we are back with one more session. The session BITSAT Prime Time with Masterclass Space is regularly conducted every day at 9 p.m. where sometimes we try to discuss concepts related to subjects. Sometimes we try to clarify doubts, confusion, give you very generic and useful information about bits Pilani, about BITSAT process, all the things. So today, friends, we will do certain questions related to a very important topic of atomic structure. So today's session is about the rules which determine how electrons are placed. So we will do those rules. So let's start with it, my friends. Yeah. Okay. Yes. So the idea is that daily 9 p.m. we are interacting so that we can develop a sense of regularity, and at the same time we can clarify certain concepts of yours. If there are some doubts, we can work on them also. Okay. So today we are taking a very important topic from BITSAT syllabus of chemistry about the electron rules, and of course, which couple of rules we have to study. We have to study Pauli's exclusion principle. That is one thing. Aufbau principle is there. That is another. Then how they determine electronic configuration of atoms and how Hund's rule plays its role. Okay. So the way we will do is not by theory, but by doing questions. Okay. To make it interesting, to make it live, we will do 6 questions and they will involve all these concepts. So without wasting any time, let's start with the first question. Yes. So friends, first and foremost, the most important thing you need to know for Pauli's principle is how is this principle exactly stated. Okay. So the way they have given is very nice, that how is this principle actually stated. So you can pause this video. You can try to attempt on your own, and then I'll share the exact answer. Okay. Yeah. Yes, I'll also try to annotate on the screen so that you are able to see whatever I'm writing. Yes, I think my writing device should work now. Yes, it is working. Okay. So friends, what you need to understand here is they are asking you about the most complete and correct statement of Pauli's exclusion principle. The thing is, many of you might feel that because in a given orbital, the way you have seen, electrons is like this. Hence, Pauli's exclusion principle might be about having opposite spin of electrons. And many of you might go ahead and write A as the tentative answer. However, that is very wrong, because the question very specifically asks you about exact, complete, correct statement. The Pauli's exclusion principle, my friends, very specifically says that no two electrons can have identical 4 quantum numbers. Okay. And the one with a spin has a plus sign, the other, like plus half, the other has a minus half. That is the difference in their 4th quantum number, spin quantum number. But that is the exact definition of Pauli's exclusion principle, but not the first one. Okay. That is very, very important. Electrons fill orbitals of lowest energy first. Friends, this is I hope all of you know, this is Aufbau principle. This is not Pauli's exclusion principle. and each orbital in a subshell is singly occupied before any pairing begins. Very famous rule, Hund's rule. And the way to remember Hund's rule always is you say its complete name. What is its complete name? Hund's rule of maximum multiplicity. So if you want maximum multiplicity, you need to keep them unpaired. Okay. So for this, our correct answer is option number B. Let's move to next. According to Aufbau principle, which of the following represents the correct filling order of orbitals? So of course, my friends, I hope all of you are aware, we have to see two things, n plus L as the priority. Wherever n plus L is lowest, that orbital will get filled first. If n plus L coincides, if two orbitals are having same n plus L, so if we have same n plus L value, then lower n, right? Lower n means lower energy. So this thing we will use, okay? And you can, of course, try to understand it correctly. So if you see 4s and 3d, okay, and 4p. So 4s, 3d, and 4p, friends. So 4s has 4 plus 0, 3d has 3 plus 2, and 4p has 4 plus 1. So of course, this is lowest. So 4s has the lowest energy. These both are 5, but then we will look at lower n for lower energy. Hence, 3d has lower energy than 4p. So the answer again would be option number B. Okay. Let's move to next question. Relatively simple, but yeah, do not get confused. Number of unpaired electron in ground state of oxygen. If they want to tweak the question, they might give, say, something like first excited state or something, a variation, but simple question. So oxygen is 1s2, 2s2, 2p4, right? This is paired, and 2p4, my friends. How will you draw it? So 1, 2, 3, and 4, which leaves you with 2 unpaired electrons. If the question asks you how many paired electrons are in oxygen, okay, how many paired electrons are in oxygen, and would you mark 2 for it? No, you do not have to mark 2. You have to mark 2 plus 2 plus 2, which is 6, because 1s2 is paired, 2s2 is also paired, and 2 of 2p4 are also paired. Okay. So do not get confused by the, at times when you feel question is way too easy, very simple, sometimes we make mistakes. So don't just look at 2p4 if you are asked about paired electrons. But here question is asking about unpaired. So yes, the answer is very simple, 2. Okay. Let's move. The ground state electronic configuration of chromium, that is, my friends, it is 3d5 4s1 instead of this. So we see a kind of exception here, right? This anomaly, what is the reason? So of course, I think you are very well aware by now that if it is something like this in P subshell, okay, or if it is something like this in D subshell, which cases I'm taking, friends? Cases with maximum unpaired electrons. So they are exceptionally stable. They have half-filled subshells and they have higher exchange energies. Okay. So due to that, there is some extra stability associated with it. Hence, this is the reason. Okay, friends. So the correct answer for this is again option B. Let's move to next question. Yeah. So if we go to next question, which of the following ions has same number of unpaired electrons? Okay. Now, of course, there are two approaches to solve this question, friends. One is that you will start quickly writing entire electronic configuration and you will try to match. That is one way. Other way, if you just pause for 1 second and see, just look at them. Fe and Co, which means the adjacent elements we are talking about, and Co has been removed with 3 electrons and Fe has been removed like 2 electrons. So what we are essentially talking about is that you are keeping both of them very same. What are you making both of them? You are making both of them as D6. Similarly, here both of them you are making as D3 and here both of them you are making as D5. So without wasting much time in drawing entire thing, making the diagram and all, just see the logic that they are talking about adjacent elements and the charge is varying by 1. So that way our answer is going to be option D. Okay, that is the thing. So this is one way in which you should save your time in your BITSAT exam. So you should see if you can do it with little more, say, some clever method instead of just going by basics. Everything you are writing configuration, iron is 4s2, that this and that. Try to like be little more specific here. Daily, we want to practice certain questions in which either we discuss some questions related to some concept or we do some, you can say, general discussion related to like what you need to do for your bits bits journey, how you should prepare for your BITSAT exam, what are the advantages of BITS Pilani as a college. All these things we try to. Okay, so stay tuned with us and keep on joining us daily at 9 p.m. So we will meet tomorrow again. Take care. Bye bye.